Section 2.4, Symmetry. We're going to talk about 3 different kinds of symmetry in this section, and also even and odd functions. I've written down a few examples for us. So looking at this first graph, first of all, just check to make sure it's a function. This one's a function. It passes the vertical line test. Okay. And then see what type of symmetry it has. Well, this one is symmetric with respect to the origin because you can turn the graph 180 degrees and you get the same graph that you started with. So you can literally turn your graph 180 degrees and see if it's the same graph that you started with to determine if it's symmetric around the origin. Okay, and if it's symmetric with respect to the origin, then you know that the graph is an odd function. And this one doesn't have any other type of symmetry in the graph, so I'm just going to say it was symmetric with respect to the origin. Looking at our second graph, again, this one is a function. It passes the vertical line test. So we can go ahead and look at the symmetry. If we fold this one along the y-axis, it matches up on both sides. So this one is symmetric with respect to the y-axis. That is the only type of symmetry we see in this graph. So this one's an even function. Symmetric with respect to the y-axis. So that shows you the 2 different kinds of examples of what an odd function, its graph would look like, and what an even function, its graph would look like. An odd function, the graph is going to be symmetric with respect to the origin. An even function, the graph is going to be symmetric with respect to the y-axis. Let's just take a look at this third graph right here. First of all, this one's not a function. It doesn't pass the vertical line test. So no matter what kind of symmetry we see in this graph, it's not going to be an even or an odd function because it's not even a function. Okay, but let's go ahead and look at the symmetry. If we rotate it 180 degrees, it is going to be the same graph as what we started with. So this one is symmetric with respect to the origin. Also, if we fold it along the y-axis, it matches up on both sides, so it's symmetric with respect to the y-axis. And if we fold it along the x-axis, it matches up on both sides, so it is symmetric with respect to the x-axis as well. So in this last graph, we see all 3 types of symmetry. All right, so that's some graphs. They're also going to give you some functions written in function notation, and we can determine if it's an even, odd, or neither for the function. Okay, so let's take a look at a few examples. F of x equals x to the 4th minus 6x squared plus 2. You can plug in a negative x to determine if it's an even or odd function. So let's take a look at what happens in this one. Plug in negative x. So we get negative x to the 4th minus 6 times negative x squared plus 2. And then do some simplifying. Well, if we're taking a negative number to an even power, that makes it a positive. So this is going to be x to the fourth minus, again, this one's a negative number to an even power, so that's going to be positive. So we'll have 6x there plus 2. Okay, well then compare it to what you started with. Notice in this one, it is the exact same as what we started with. If you get the same thing as you started with, then this is an example of an even function. Let's try another one. F of x equals x to the fifth plus x cubed minus 2x. Again, I'm going to plug in a negative x and see what happens. So I've got negative x to the fifth power plus negative x to the third power minus 2 times negative x. Okay, well, when we've got a negative number raised to the odd power, it stays negative. So this is going to be negative x to the fifth. Again, a negative number to an odd power, so that'll be minus x cubed. And we've got a negative times a negative, which is a positive. Well, look at what happened in this one. All of the signs switched. Okay? Has to be all of the signs change. If that happens, that's an example of an odd function. Okay, so if all the signs stay the same, it's an even function. If all the signs change, it's an odd function. If only some of them change, then it's neither. So let's take a look at my last example. F of x equals x to the sixth power plus x cubed minus 2. Okay, I'm plugging in a negative x. And I see that I've got a negative to an even power, so that's going to be a positive x to the sixth right there. This one's a negative to an odd power, so that one's going to be a minus x cubed, and then minus 2. And notice in this one, the first sign stayed the same, the second sign changed. Well, right there we see that some of the signs stayed the same, some of them changed, so this one's neither. Okay, you may have noticed with these 3 examples something else that would tell you whether it's even or odd. If you're given a polynomial, you can look at all of the exponents. If all of the exponents are even, then it's an even function. If all of the exponents are odd, then it's an odd function. If you have a mixture, it's neither. Just be careful. Okay, let's look at this first one that we did. My power was 4, 2, and I have a constant. Well, you have to remember to put an x to the 0 power next to your constants. Still have to look at the power for that term. Okay, so I've got a 0, 2, and 4. All of those numbers are even, so it was an even function. Okay, in the second one, we've got 5, 3, x with no power written, we know is the power of 1. So we've got 5, 3, and 1. All of those are odd numbers, so we've got an odd function. In our last one, we have 6, 3. We don't really need to look at this one because we have 2 different, an even and odd number already, but just remember, you should look at your constant, that's a 0. So I've got 2 evens and an odd. Well, I have a mixture, so it's neither. Okay, so do what works best for you. If you're given a polynomial, you can look at the powers. Just make sure you look at all of the powers. Or you can do this test where you plug in negative x and see what happens. And that's it for today.